Buenas noches. Good evening, everybody. Welcome to day 2 on week 6 of the semester. Right now, we are just observing in the screen the last thing that we mentioned in class on Tuesday, which was how can we draw the condensed and the skeletal structure for a given alkane molecule. So when it comes to alkanes, you can see that when it comes to the condensed structures, we are going to illustrate all of the atoms there, the carbons, the hydrogens, and whatever substituent you have. Then in the skeletal structure, you're going to only illustrate atoms that are not carbons or hydrogens. So as you can see, we have one more problem here. And in the last problem, the alkane name is going to be 4-isopropyl decane. Okay, so let's utilize the chat just to remind ourselves how do we build this. So if the name of my alkane is 4-isopropyl decane, how many carbons in the longest continuous chain of carbons, meaning the parent chain or the functional group? Excellent job, 10 carbons. So we are going to draw 10 carbons in a row. 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the number 4 tells us that on carbon 4, we have an isopropyl group. So on carbon 4, let me just put the numbering. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So on carbon 4, we have an isopropyl group. Isopropyl is a CH group that on both sides, it has CH3. So there's 3 carbons total in the side chain, in the branch. That's why it's called propyl, but it's isopropyl because instead of being attached to the main chain through one of the corner carbons, we're attached through the middle. Do not forget that it is important that you know how to write the correct number of hydrogens for these atoms. So when it comes to this, carbon 1 and carbon 10 are going to have the same number of hydrogens. So how many hydrogens do we have to place on those corner carbons? Let's put it in the chat. How many hydrogens do we need to put in those corner carbons? Excellent job, 3. So this is a CH3. This is a CH3. Understand that in organic chemistry, it doesn't matter if you write it as H3C. That means that those hydrogens belong to that carbon. Or like I wrote it in carbon 10, CH3. Either notation, it represents a carbon with 3 hydrogens. Now, as we move along, carbon 2, carbon 3, 5, 6, 7, 8, and 9 have the same number of hydrogens because they already have 2 bonds. So how many hydrogens are we going to place in all of them? Great, excellent. I like to see those 2s in the chat. So this is a CH2, this is a CH2, this is a CH2, 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 and CH2. Lastly, carbon 4 already has 3 bonds attached to it. So how many hydrogens are we going to place on it? Great. Only 1. And this gives rise to our condensed structure. When it comes to the skeletal, remember, once your writing utensil touches the paper, that's carbon 1. And then we point up carbon 2, down carbon 3, up carbon 4, down carbon 5, up carbon 6, down carbon 7, up carbon 8, down carbon 9, up carbon 10. Okay. Now, specifically, carbon 4 is the one that is going to have that isopropyl group. And the way that we illustrate isopropyl groups in the skeletal form, you guys, it actually looks like a Y. Because this is the CH group. This is the CH3, and this is this CH3, okay? Any questions when it comes to alkanes with one substituent? Great. Then now let's move on to how do we name alkanes that have two or more of the same substituent? As you can see, step one is always the same. We're going to write the alkane name of the longest chain of carbon atoms. Remember that this is what I refer as the parent chain. Or at times in exams and quizzes, you may see it as illustrated as like functional group name, okay? So you guys don't get confused of that in the future. Now, similar to what we learned previously, we're going to number the carbon atoms starting from the end that is nearest to a substituent. Now, when it comes to having two or more of the same substituent, let's understand that we are going to have the name of the substituent, but to imply multiples, then we have to put a prefix before the name of the substituent. So if there's two, you're going to put di. If you have three, you put tri. If you have four, it's tetra. And then from there, the Greek prefixes, penta, hexa, hepta, so on and so forth. Then understand that you have to give the location of each of the substituents, and you're going to separate them by a comma. Similar to what we learned before, every time we have numbers and words, we're going to separate them by a hyphen. So let's go over the example that we have here, which is the condensed structure. So in my condensed structure, I can see that I have these. Make this a little bit thicker. This is the longest chain of carbon atoms, okay? So I have specifically 6 carbon atoms. I'm going to start numbering them from the left. 1, 2, 3, 4, 5, okay? I counted too many, there's only 5. So these 5 carbons, okay? What will be the alkane name for the parent chain or the functional group name? Because we're still dealing with alkanes. If I have 5 carbons in the longest continuous chain, what is the name of that? Great job. Pentane. Now, we can see that we have 2 branches, 2 side groups. We have 2 CH3s, okay? What is the word that we utilize for a branch that is a CH3? Excellent, thank you, Guillaume. Methyl. Since we have 2, what's the prefix for 2? Thank you, Katie and Daisy. Di. Then I'm going to put a hyphen, and then I'm going to put the location for the methyls. Notice that both of them are on the same carbon, so I'm going to say 2,2-dimethylpentane, okay? One of the things that I find is that students do not put the correct numbers for the substituents when they have multiple. They're like, oh, they're both on carbon 2, so I'm just going to put 1, 2. As long, you guys, as you have this prefix, you have to give me 2 numbers. So if you say try, because there's 3 of the same, you have to put 3 numbers. You have to give the location for each of the substituents. Let's look at the following example, which is a skeletal molecule, okay? So take a moment, find the longest carbon chain for the following skeletal structure. And let's put it in the chat. What is the longest carbon chain that we have here? How many carbons? Excellent. That's as many as I counted also. 1, 2, 3, 4, 5, 6, 7, 8. Now, when it comes to this, I need to number this from the end that is nearest a substituent. So I can say, okay, I'll go 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. So for this molecule, it does not matter if I number it left to right or right to left, because my two substituents are on the same positions, on 4 and on 5, okay? So I'm just going to leave the numbering right there. But what would be the name that describes the parent chain? So those 8 carbons. Great job, you guys. Octane. And then what kind of substituent is this? Let me highlight it. What kind of substituent is this? What kind of group is that? It has 2 carbons. There's only one substituent with 2 carbons that you guys know. It's not gonna end in ane. It has to end in YL. Great, exactly, ethyl. Those 2 are ethyl groups. And as we just saw in the example above, we have 2 of them, so we are going to use the prefix di. And then we're going to say, okay, on position 4 and on position 5, I have 2 ethyl groups on my octane chain. So the name of this molecule is 4,5-dimethyl octane. Put a 1 in the chat if you're ready to practice. Let's practice naming. Great. For practice, let's do the 2 middle structures. This one and this one. So I'm going to give you guys a couple of minutes to come up with the names for those 2 structures. Put a 2 in the chat if you finish both problems. Okay, I have 2 people, 3 people. I have 14 students here. 4 people finish. 5 people finish. What happened to the other 9 people? There you go. We're getting there. We're getting there. Awesome. So if at least you finish the first one, let's go through that. Let's find the longest carbon chain, which is here. Okay. When we number it, there's 1, 2, 3, 4, 5, 6, 7. So that means that the alkane name is going to be heptane. I have 2 chlorines on it. I use the word chloro for them. Since I have 2 of them, is di. And we can see that they are on carbon 2 and on carbon 4. So I put 2, 4. Okay. Put a 1 in the chat if you got the first one correct. Great. Love to see those ones. Let's move on to the next molecule. In the next molecule, my longest carbon chain is here. The number of carbons is going to be 1, 2, 3, 4, 5. Since I have 5 carbon atoms, then this is going to be pentane. Since I have fluorine as my substituents, this is going to be a fluoro group. Since there's 3 of them, the prefix is tri. And then I'm going to put their positions. I have a fluorine on carbon 1, 1 on carbon 2, and also 1 on carbon 4. So put a 2 in the chat if you got that one correct. Great. If you didn't get that correct, don't worry, practice. You guys have lab 3B, and you also have the in-class worksheet that you can practice from, okay? So now that we know how to name alkanes with 1 substituent and alkanes with 2 of the same substituents, let's move on to learn how do I name alkanes that have different substituents, okay? So one of the things is that when it comes to this, we have to, as you can see, in step 1, just find the longest carbon chain, and we're going to write the alkane name for it. So that step, as I mentioned to you guys, is always the same one, okay? Then we're going to number the carbon atoms, starting from the end that is nearest a substituent. Now, it is important to note that when it comes to having different substituents, we're going to give the location and the name of the substituents, but we're going to utilize the name of that substituent for alphabetization. So with different substituents, we're going to add them in alphabetical order. All of that is going to be a prefix of the parent chain, okay? So let's go through the first example. Here we have a condensed structure. Give me one moment. So let's find the longest carbon chain that we have in this structure. So when it comes to this, we can select this one, or we can select the CH3 pointing down. Regardless, it's going to be the same longest carbon chain, okay? So by selecting that, we can see that we need to number this starting from the far left, okay? That's one possibility. So we can say, okay, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. You could also think about putting the numbering in the other direction. Let me just change really quick the number 2 and just put it above. So this is 1, 2, 3, 4, 5, 6. So the thing is that when it comes to this, let's understand that the one that gives us the overall lowest for all of the substituents is the correct numbering. Don't be guided by just saying, I was like, well, the substituent starts at 2 regardless on any direction. There is a correct way, okay? Now, as practice, you guys, I'm going to highlight the substituents here. What is the name of the substituent that is labeled F? What is the name of that? Great, this is a fluoro group. What about the one that is CH2CH3? Great job for the people that are putting in the chat. You guys are doing very well. The CH2CH3, how do we call it? Excellent, that is an ethyl group. And what about the CH3? What is the name of that? That's a methyl group, great job. Now, in the red numbering, we can see that that fluoro group will be in position 2. The ethyl will be in position 3, while the methyl will be on position 5. Okay, if we look at the numbering in the blue direction, that will give the methyl a position 2, then the ethyl will be on position 4, and the fluoro will be in position 5. So you may be wondering, okay, how do I pick if my arrangement is going to be 2, 3, and 5 versus 2, 4, and 5. There is a simple trick on how to know which way is the correct numbering. Is if you add the numbers, okay? And this is just a trick. Don't think that you have to add the numbers. This is just to say, okay, the red one is okay or the blue one is okay. If I add my numbers, 2 plus 3 plus 5, that equals 10. But if I add 2 plus 4 plus 5, that equals 11. So since this is lower number, that means that the red is the correct. Okay? Put a 1 in the chat if that makes sense. I want to make sure that you guys got that little trick. Excellent. So that means that the blue way to write it is not correct. So we're going to keep the blue arrangement. And now, since we know the correct positions for my substituents, then I'm going to start writing the name. So since my longest carbon chain has 6 carbons, my parent chain is called a hexane. Then I'm going to alphabetize my substituents. So the first one that comes in alphabetically is going to be my ethyl group. So I put 3 ethyl. There's a dash between the 3 and the ethyl. Then I have the fluoro group is the one that comes next alphabetically. 2 fluoro. And lastly, I have the 5 methyl. So the name of this compound is 3-ethyl 2-fluoro-5-methyl-hexane. Okay? Questions on the first example? Then let's move on to the skeletal structure. Okay? So in this skeletal structure, let's find the longest carbon chain. When it comes to the longest carbon chain, this is going to be the longest carbon chain. Okay? I can number this from left to right. 1, 2, 3, 4, 5, 6. Or I can number it in the opposite direction, where this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay? I want you guys to take a moment and write in the chat if I'm going to number this based on the blue numbering or the red one. Let's pick a color. What is the correct arrangement for numbering this molecule, blue or red? One vote for blue. I got 14 students. Great, I see more blues. Great, great job, you guys. I agree with you guys, the blue one. Because our choices are going to be either 2, 4, 5, which is 11, or 2, 3, 5, which is 10. So let's erase the red, which is the incorrect numbering. I'll highlight the parent chain in a moment. So I write the name of the longest carbon chain, which is hexane. Okay. Then, as we can see here, I have 2 substituents that are the same and one that is different. Okay. So the 2 substituents that are the same are going to be the fluorine and the fluorine. So I have a difluoro group that specifically is on position 2 and 5. And in position 3, I have a bromo group. Okay. So who comes first alphabetically, fluoro or bromo? Because one of the things that I want to specify to you guys as we get into more complex structures, alphabetization, you will be comparing what I highlighted in yellow, which is the F in fluoro versus the B in bromo. Prefixes, di, tri, tetra, do not play a role in alphabetization. We're alphabetizing by the name of the substituent. Great job, you guys. I agree, bromo comes first. So when it comes to this, I put 3 bromo, 2,5 difluoro hexane. That's the name of this molecule. Put a 1 in the chat if you're ready to practice. Great. So here we have the following molecules, okay? I want you guys to take a moment and name the 2 molecules that we have on the right side of the slide, the one that I put check marks. I'm going to give you guys 3 minutes to name those 2 molecules. Put a 2 in the chat if you finish both problems. Oops, let me reconnect. Okay, then put a 1 in the chat if at least you finish one of the 2. Okay. Then let's go over the top problem. What is the longest carbon chain in the molecule on the top? Let's put the number in the chat. What is the longest carbon chain? I agree with Maria. There's 9 carbons in the longest carbon chain here. Starting here, carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let's do the numbering. 1, 2, 3, 4, 5, 6, 7, 8, 9. Versus 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So in both directions, in the red one and in the blue one, my substituents have the same numbering. Okay. So what happens when in both directions your substituents have the same numbering? There is something that breaks the tie, and that is going to be alphabetical order. So let me just write it as a note. When in numbering, substituents, the position of the substituents is the same in either numbering So in this case, let me illustrate it. In the red, we will say 4-ethyl, 6-methyl, or in the blue, which is 4-methyl and 6-ethyl. Then alphabetical order is used to determine the correct numbering order. Okay, this is just a very special case. In any direction, and we can see it, I wrote it there, is 4 and 6, 4 and 6. So when we add them, they're both 10. So when it's both 10, instead of saying like, oh, it could be whatever, no, then alphabetical order is what's going to determine who wins. So who's gonna win here, you guys? Red or blue? Great job, red. Because Ethel comes alphabetically first, then we're going to give it the lowest number. This rule only applies if your alkane numbering is the same in either direction. Please do not use alphabetical order to determine your numbering in any other instance. We always have to do it based on numbering or start numbering the longest carbon chain closest to the end nearest a substituent. It's just that in this example, I'm illustrating a case in which, wow, okay, it doesn't matter which way I number it, it actually gives you the same number. So how do we determine which one it is? Well, alphabetical order. So when it comes to this, as you guys said, the red one is the one that is the correct one. So let me erase the blue. And now let me name this molecule. My longest carbon chain, the parent chain, because there's 9, that is nonane. Then my substituents is 4-ethyl, 4-ethyl, 6-methyl, nonane. Any questions about the top example? Then let's move on to the lower one, okay? In the lower one, okay, how many carbons in the longest carbon chain? Let's put it in the chat. I agree, 6 carbons. Those are the 6 carbons. That means that the parent chain, we're going to name it as a hexane. Remember that in alkane, you guys, unless you have a substituent that is a halogen on carbon 1, then it goes from CH3 to CH3. The only alkane that doesn't go from CH3 to CH3 is if in carbon 1 you have a halogen, okay? Now, when it comes to numbering, I have to number this from right to left to give the substituents the lowest number. This is the n nearest a substituent. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So here I have 2 substituents that are the same. On carbon 2 and on carbon 4, I have a dimethyl group. On carbon 3, I have a fluoro group. Now, remember that when I'm alphabetizing something, my alphabetical order is by the name of the substituent. So M versus F. So M in methyl versus the F in fluoro. So because of that, the first substituent that I'm going to write in is the 3-fluoro, followed by the 2,4 dimethyl. And then the last word is hexane. Any questions about alkanes with one substituent, multiple substituents that are the same, or different substituents? Go ahead, Dominique.
In that last problem we just did, with the dimethyl group, it's like if you add those 2 together, it equals 6, which is bigger than 3. But in this case, we would just go alphabetically instead of like adding.
So remember that whole thing of adding is when you're comparing overall. So the comparison is not so much the 2 and the 4. The comparison with the adding thing is if you were numbering this as 1, 2, 3, 4, 5, and 6. And in the blue arrangement, then you have 3,5 dimethyl. And then your fluoro is on carbon 4.
Okay, I see.
So then you will say, okay, 5 and 3, that's 8, plus 4, that's 12. And then the one that I have already, that is going to equal 9. So that's how I know that the correct arrangement is what I wrote as the answer.
Right. Okay. Thank you.
No problem. That's a good question. Any other questions? Then let's move on now to name alkanes, which are cyclic. Okay, so alkanes can also come in cyclic form. And understand that when you have an alkane that is in cyclic form, it's going to have 2 fewer carbons compared to the open chain alkanes. So for cycloalkanes, the chemical formula is going to be determined as CnH2n minus 2, okay? So that means that, for example, when I'm trying to determine what is the smallest cyclic alkane, understand that it's going to be 3 carbons. So when N equals 3, I know that it is C3H2 times 3 . Wait, it's not minus 2. It's just CnH2n. So the chemical formula for the smallest cyclic alkane is C3H6. The H2n minus 2 is for the alkynes. So again, cyclic alkanes are going to have that general formula. And you can see here examples of cyclic alkanes. Now, our cyclic alkanes are going to adopt geometrical shapes. So you can see that this is the one that has 3 carbons. This is the one that has 4 carbons. This is the one that has 5 carbons, 6 carbons. You can have 7 carbons, 8 carbons, 9 carbons, 10 carbons, so on and so forth, okay? When it comes to cyclic alkanes, in terms of the naming, you know that you're dealing with a cyclic alkane because the prefix cyclo is going to be before the name of the alkane. So how do we name the smallest cyclic alkane, which is the first one that we have here? Well, we write the word cyclo because it has 3 carbons. This is pro. And then because it's an alkane, ane. So this is cyclopropane. 4 carbon cyclic alkane, this is cyclobutane. 5 carbon cyclic alkane, cyclopentane. What would be the name of the 6 carbon cyclic alkane? Let's put it in the chat. Great job. Cyclohexane. Okay, let's learn now how to name cyclic alkanes. Okay, so the only examples that we have for cyclic alkanes, you guys, is going to be cyclic alkanes with 1 substituent or cyclic alkanes with 2 substituents. When we have a cyclic alkane with 1 substituent, all we have to do is write the name of the substituent followed by the cyclic name of the alkane, okay? So as we can see in the example here, we have a bromo group attached to something that looks like a pentagon. Well, that is cyclopentane. So the name of this structure is bromocyclopentane. So when you have two substituents in a cyclic alkane, understand that you're going to number the ring clockwise or counterclockwise. But the substituent that gets the number one is going to be the one that that comes alphabetically first, okay? So when we look here at the bottom example, okay, we have two substituents. One I labeled in blue. The other one I'm labeling in purple. Okay. What is the name of that skeletal structure with the blue substituent? What is the blue substituent? Let me make sure that everybody knows how to look at molecules in both skeletal and condensed. What is the blue one? It's only one carbon. What is the substituent in blue? Great. That's a methyl group. What about the one in purple? It's two carbons. Great. That is an ethyl group. So since ethyl comes first alphabetically, then the carbon that is holding that in the ring is going to be carbon 1. Then I'm going to number the rest of the ring to give the next substituent the lowest number. So in this case, I have to go counterclockwise. 1, 2, 3. And when I name this cyclic alkane, I'm going to say 1 ethyl, 2 methyl, cyclo, propane, because I know that inside my ring, I only have 3 carbons. Let's practice naming the following cyclic alkanes. As you can see, the ones on the top are going to have 1 substituent. The ones in the bottom are going to have 2 substituents, okay? So I think we can do this fairly quickly. What would be the name of let me just number them. I think that will make it easier. If this is 1, this is 2, this is 3, and this is 4. Let's name 1 and 2. What would be the name of number 1? We have 1 substituent and we have a cyclic alkane that looks like a triangle. Okay, you guys, when we only have 1 substituent, we don't have to put a number because wherever it is in the ring is going to be number 1. So we have to not put the number 1, and this is methyl, cyclo, propane. Okay. What about number 2? What will be the name of that second cyclic alkane? In this substituent, we have 1, 2, 3 carbons. Great. Propyl, cyclo, heptane. Okay, because in the ring system, we have 1, 2, 3, 4, 5, 6, 7 carbons. Questions on cyclic alkanes with 1 substituent? Then let's move on to 3 and 4, okay? On number 3, on the left side, I have a methyl group. On the right side, I have an isopropyl group. So when it comes to alphabetization, I'm comparing specifically the I in isopropyl to the M in methyl. So who gets carbon 1? Which group will get carbon 1? The isopropyl, exactly. So this is carbon 1. And then I go, this is 2, this is 3, this is 4. The reason why I went counterclockwise is so I can give the methyl the next lowest number, okay? So when I write the name of this is going to be 1 isopropyl, 2 methyl. What is the name of the parent chain, the cyclic? It has 4 carbons. Great. Cyclobutane. Don't forget the cyclo. Let's move on to the last one, to number 4. This substituent has 2 carbons. So this is an ethyl group. This substituent only has 1 carbon. This is a methyl group. So who gets carbon 1? Great, the ethyl group. So this is 1, this is 2, 3, 4, 5. So this is going to be 1 ethyl, 2 methyl, cyclopentane. Watch out with the numbering. It's 1 ethyl, 2 methyl cyclopentane. Remember, when you have 2 substituents in a cyclic alkane, who gets position number 1 from the carbon inside of the ring is going to be the one that gets alphabetized first. Okay? Any questions? Naming cyclic alkanes. Great, let's move on to the next topic, which is going to be alkenes and alkynes. So alkenes and alkynes are 2 more members of the hydrocarbon family. The difference between alkenes and alkynes is that alkenes have a carbon-carbon double bond in their structure. Alkynes have a carbon-carbon triple bond in their structure. Now, we call alkanes saturated hydrocarbons because they have the max number of hydrogens that you can fit in those structures. When it comes to alkenes and alkynes, they are called unsaturated hydrocarbons because they do not contain the maximum number of hydrogen atoms that a carbon can hold, okay? Now, where do we see alkenes in everyday life? Well, here I wanted to bring you guys an important biomolecule that is called lycopene, okay? Put a 1 in the chat if you have heard of lycopene before. In commercials, maybe in everyday life. People haven't heard of lycopene? Well, lycopene is found in many fruits and vegetables and is contained in high amounts in tomatoes. That's why you have a tomato right there. Lycopene is actually known as a biomolecule that has antioxidant properties. So that's why at times it has been suggested to take lycopene as a supplement. But one of the things that is known about lycopene is that the red color that we have in tomatoes is thanks to this molecule. Now, we can see that in the word lycopene, the ending of the name ends in -ene, okay? And then when it comes to alkenes and alkynes, we can see, oh, lycopene. When we look at the structure, look at all the different double bonds that we have. So the -ene ending in the name gives us an idea that we have carbon-carbon double bonds in the structure. Now, I want to specify, you guys, that when it comes to naming alkenes and alkynes, that is not given in your textbook. So I think it's important that you guys know how to name alkenes and alkynes, just because it's very relevant when it comes to biochemistry. So I'm going to at least teach you guys how to name alkenes and alkynes. So the rules for naming alkenes and alkynes are given in the following slides. Give me one moment. So these are the rules for naming alkenes. We're going to find the longest carbon chain, but when we're dealing with alkenes, that longest carbon chain needs to include both of the carbons in the carbon-carbon double bond. Then we're going to name the molecule with the alkane name, and then we're going to erase the A and E ending and replace it with ENE to represent that we have an alkene. We're going to number the carbon atoms starting from the end that is nearest the double bond. So we're going to give the priority in numbering to the carbon-carbon double bond. And then we're going to be, numbering the rest of the substituents wherever they are in the molecule. But again, in order from the double bond point of view. So we're going to prioritize to give the lowest number to our carbon-carbon double bond. Then understand that there's some double bonds that may be equidistant. And equidistant means that it doesn't matter that if you number it in either direction, they're going to give you the same numbering, okay? If you have an equidistant alkene, then the numbering is going to be based on the carbon at the end that is closest to the substituent, to the first substituent. And then as we have done before, we're going to give the position and the names of the substituents in alphabetical order as a prefix of the parent chain. So the parent chain now is going to be our alkene, and we have to also include what is the first carbon in our alkene. So let's do examples for naming alkenes so we see how these rules are illustrated. So here is a skeletal structure for an alkene. I am first going to identify the longest carbon chain. Here I have 1, 2, 3, 4, 5. So 5 carbons, we learned that the alkane name for that is pentane. But because we're dealing with an alkene, we're going to erase the ane and put ene, pentene. I'm going to number the carbon atoms starting from the end that is nearest the double bond. So for this alkene, I have to go 1, 2, 3, 4, 5, okay? Then I need to give the location of the first carbon for the carbon-carbon double bond. So when it comes to this, this is 2-pentene. Now, we just finished naming when substituents have, or when we have two substituents that are the same. So those rules we just learned, we cannot forget about them. So in this molecule, as you can see, we have two substituents that are the same. So for this molecule, I'm going to say dimethyl is my two substituents. And then one is on carbon 2, the other one is on carbon 4. So the name of this molecule is going to be 2,4 dimethyl 2-pentene. Questions on the first example? Then let's move on to the next example. Here we have another alkene. Let's find the longest continuous chain of carbon. We have 6 carbons in a row. So let's put it in the chat. What would be the alkene name if I have 6 carbons in a row? Great job, Vanessa. Hexene. Now, I'm going to number this in 2 directions. I'm going to say 1, 2, 3, 4, 5, 6 versus 1, 2, 3, 4, 5, 6. This is an example of an equidistant alkene. Why is that? It doesn't matter if I go left to right or right to left. My alkene is always between carbons 3 and 4. Put a 1 in the chat if that makes sense. Okay, I want you guys to be observant about this. So it doesn't matter if I number this left to right or right to left, they are between carbons 3 and 4. So regardless, I'm going to have a 3-hexene. Now, based on the rules that I just gave you guys, one of these 2 numbering systems is correct. So when we have an equidistant alkene, we have to keep in mind that the correct numbering will be the one that starts at the end nearest a substituent. This only happens in equidistant alkenes, okay? So based on that, what's the correct numbering, red or blue? I don't agree with blue. Let me explain why red is the right answer. We understand that regardless of red or blue, my alkene is going to be 3-hexene. Put a 1 in the chat to make sure that that is solid in your brain. Good. So in the blue arrangement, which was the first one that people were putting, I'm going to say, oh, okay, in the blue arrangement, my substituents are going to be 2-methyl, 6-fluoro, or actually in alphabetical order, 6-fluoro, 2-methyl. But in the red arrangement, I'm going to have a 1-fluoro, 5-methyl. So which end gives me a substituent numbering that it totals the least value? The red or the blue? Great, the red, right? That trick we learned a few moments ago. Remember that you have to be careful with that. Don't generalize it. There's going to be specific moments when we utilize it. Specifically, when we have different substituents. That's when we use that rule. So because of that, then the red numbering is the one that is correct. So my substituents here are going to be 1 fluoro, 5 methyl, 3 hexene.
I still don't understand why it's 3 hexene.
No problem, Vanessa.
Okay.
When you look at the numbering, right? The first carbon in the carbon-carbon double bond has a digit of 3. So your carbon-carbon double bond is between 3 and 4. So I need to
So
put the
That's
first
to do with the double bond?
that has to do with the double bond.
Okay. Okay.
Because what happens is that when you have alkenes, you cannot say hexene and that's it, because it could be between 1 and 2. The double bond can be between 2 and 3. It could be between 3 and 4. You see what I mean? So that's why in alkenes, not in alkanes, because alkanes don't have that issue. Alkenes, we need to give the location for the carbon-carbon double bond because it could be anywhere.
Okay, I get it. Thank you.
No problem. So see, like above, if we had it, you know, somewhere else, well, it's a pentene. So regardless, it's going to be between 2 and 3. But if you have larger alkenes, like you have 7 carbons, 8 carbons, you know, it could be in between different numbers of the carbon atom. So you always have to give the location of the first carbon in the carbon-carbon double bond. Let's practice, you guys. So here we have IUPAC names, and we have to draw the condensed and skeletal structure for them, okay? So let's look at the first one. 3-ethyl, 1-pentene. If it's pentene, how many carbons am I going to have in the parent chain? Excellent. Thank you, Katie and Daisy. 5. 1, 2, 3, 4, 5. You guys see that value of 1? That means that my carbon-carbon double bond is in between carbons 1 and 2. Teresa, did that make sense? Why now we have a 1 before the pentene, so the carbon-carbon double bond is between 1 and 2. Awesome. Now on carbon 3, we have an ethyl group. An ethyl group is a CH2, CH3. Let's be careful when we're adding our hydrogens, okay? Because when we have alkenes, remember, the rule of thumb is my carbon atoms need to have 4 atoms overall, 4 bonds, okay? So how many hydrogens does carbon 1 need to complete its octet? Let's put it in the chat. How many carbons? Oh, sorry, how many hydrogens on carbon 1 if it already has 2 bonds? Thank you, Dominique. It needs 2, so this is a CH2. Carbon number 1 has 2 bonds to carbon number 2, so it only needs 2 more hydrogens to complete its octet. What about carbon number 2? It has 3 lines around. Thank you, guys. Exactly, only 1 hydrogen. What about carbon 3? Also 1. Awesome job. What about 4? Great. And carbon 5. Excellent. So when we go and draw this, you guys, for the skeletal, we say this is carbon 1, this is carbon 2, This is carbon 3, carbon 4, carbon 5. I need to be intentional about my carbon-carbon double bond, which is between 1 and 2. So make sure that you write 2 lines between carbon 1 and 2. Okay? Then on carbon 3, because this is 1, 2, 3, 4, 5, since carbon 3 is pointing down, you guys see the vertex. It looks like a valley. It doesn't look like the top of the hill. It looks like a valley. Then I'm going to say, this is the CH2, this is the CH3. And that's the skeletal structure for 3-ethyl 1-pentene. Put a 1 in the chat if you want to see at least one more before I let you guys go. Okay, let's do the second example pretty quick. 2-bromo 3-methyl 1-butene. If it's a butene, how many carbons? Put it in the chat. If it's a butene, how many carbons? Great. 4. So since I have 4 carbons, the number 1 tells me that it's in between carbons 1 and 2 that I have the carbon-carbon double bond. On carbon number 2, I have a bromine. On carbon number 3, I have a methyl group. Now, I could have drawn that methyl group pointing up towards the bromine. I just made it pointing down just because of space. So understand that you can draw both on top, both on the bottom, one up, one down. I just did it because of space, okay? Now I add my hydrogens. My carbon number 1 gets 2 hydrogens because it only has 2 lines to carbon number 2. Carbon number 2 gets no hydrogens because it already has 4 lines. Carbon number 3 gets only 1 hydrogen. Carbon number 4 has 3 hydrogens, okay? Put a 1 in the chat if the addition of the hydrogens makes sense. Great. Now let's draw the skeleton. This is carbon number 1, to carbon number 2, carbon number 3, to carbon number 4. I have a carbon-carbon double bond between 1 and 2. On number 2, I have a bromine. On carbon 3, I have a methyl, so it's just a line. And I have carbon 4, which is a CH3. So that's the skeletal structure for 2-bromo 3-methyl 1-butene. Any last minute questions before I let you guys go? Daisy, I'll answer your questions in a moment. If you have to go, no problem. I'm just going to stop the recording right here.